Wanted to design a guitar amplifier using these compactron tubes. Two of them here are compactron tubes. One is the output tube 6DZ7. I have several of them laying around here, so I figured I'd give it a shot of using it as a push-pull output stage. And then I'm going to use the 6U10 as the preamp and phase inverter, and what will be the dirty channel of the amplifier, the super amplification input, a 6AV6, which has pretty much the same specs as a 12AX7, only this is just a single section. It has a couple of diode sections that I won't be using, but this tube here will be a nice low noise input tube for the dirty channel of the guitar amplifier. So I'm going to draw up a block diagram here and see what I can come up with for a 3-tube guitar amplifier. Here's the specs on the 6DZ7 output tube. There are certain things needs to be considered when using it in a push-pull output stage. For one, the screen grids are tied together. They're tied together to pin 4. The cathodes of each section and the suppressor grids are all tied together at pin 8. The plates are separate and the control grids are separate. So you can't use taps on the output transformer to drive the screen grids. So the screen grids will have to be resistively driven from the main plate voltage. That is one of the limitations of using this tube. It has about the same wattage as a 6V6 or 6BQ5s. The voltage of this tube is a little higher at maximum 440. I'm going to run it at about 400. Other than that, going to use it in push-pull using a fixed bias applied to the control grid. That should be around minus 11 volts, so I'll have to generate a negative voltage for the grids. But anyway, this is going to be the tube I'm going to make as the output tube, and hopefully it will work out. This is the output transformer I chose, which is the 20-watt version of this Hammond. The one I'm using is a 1620, which is a 20-watt transformer. It's 4, 8, and 16 ohm selectable. It has a chart here that shows they call out a 6AQ5, 6L6, or 6V6 to be used with this transformer. This is the wiring diagram. One thing that bothers me about Hammond, they don't put where the start is of the windings. Probably be using negative feedback from one of the output taps of the transformer, and I need to know the phase for that. So I'll have to test to get that phase information, because they don't designate it here on the windings themselves. I'm using the Hammond transformer only because I happen to have it. It's not going to match up well to this 6DZ7. The load resistance here on the output tube is 9,000 ohms. The transformer is 6,200, so it's way off. But I'm going to use it for now. I have found a better transformer to use. These are some of the figures for the Hammond 1620. It's 6,600 ohms. And with the 6DZ7 being a 9,000 ohm, that gives us pretty bad output impedances of 21.8 for the 16 ohm, 10.9 for the 8 ohm, and 5.4 for the 4 ohm. So that isn't going to work the best. I found a better transformer. I'll try to get hold of one in the future. There seems to be a delay getting them because of materials. It's an Edcore CXPP25-8K, And this will get me a lot closer. This transformer is an 8,000 ohm. If I calculate that out, I'll get 18 ohms for the 16, 9 ohms for the 8 ohm, and 4.5 for the 4 ohm taps. So that is much closer, not perfect, but that would work better than the Hammond transformer. But I'm going to go ahead and use the Hammond for now, just because I have it and I can't get a hold of the other ones yet. This is the Ed core that matches up about the best to the 6DZ7. It has the same winding arrangement, common 4 ohm, 8 ohm, 16 ohm, B plus, and push-pull. And like I mentioned before, I can't really use the screen grid taps with this tube because the screens are tied together. It has pretty good specs. It's a 25 watt instead of a 20. It has 8K of primary impedance, and the 6DZ7 has a 9K. So that's about as close as I'm going to get for now. Going to use the 6U10 here. I'll be using section 2 is equivalent to a 12AX7. It has the highest gain. So I'll be using that as the preamp, and that'll be used as the clean input for the amplifier, and the 6AV6 will be put in front of this preamp for the dirty side of things. And then the other two are lower mu, and one will be used for the tone control buffer, and the other will be used for the phase inverter for push-pull. As it says here, sections 1 and 3 are different than section 2. And if you look down here, you'll see that section 2, these numbers are pretty close to the same as a 12AX7. These two, I believe, 12AU7, I think they're equivalent to a 12AU7. So we're going to be using this tube as the preamp, and 6AV6 here, very high mu triode. It is like one section of a 12AX7. In fact, if you look at the specs here of 80,000 to 62,500 ohms for plate resistance, and the transconductance at 1250 and 1600 here, that's pretty much equivalent to a 12AX7. And then it's got a couple of diodes that I won't be using, probably for detectors in radios and so on, diode detectors. So this will be the dirty tube, as they call it, in the amplifier for super high gain, getting that clipping effect from the guitar. So those are the 3 tubes I'm going to use, and the output transformer I'm going to use. Okay, this is what I propose for this guitar amplifier. Here at the input, I'm going to come into the clip amp and the preamp in parallel, so I can bring in the clip amp to the preamp with just a relay contact. So from clean to dirty, it'll just be this relay. So the inputs are paralleled. The clip amp is disconnected from the preamp until the relay's pulled. Once the relay's pulled, the clip amp drives the preamp directly and disconnects it from the input. So I'm going to give that a try. This is section 2 of the 6U10, which is equivalent to the 12AX7. The output of that goes to the tone control and also the bright relay. So there's a bright circuit here and a bright control. The tone circuitry and the bright control will go into section 1 of the 6U10 as a tone buffer. That also will take in the feedback. I've got a feedback network from the 8 ohm output of the transformer into the tone buffer amplifier, because after the tone buffer it's pretty much linear all the way through. So we're injecting the feedback here. Then we have the phase inverter, which is 6U10 section 3, and that gives me a plus and minus signal for the 6DZ7 output tube. It's going to be fed with a bias into the control grids. So there'll be a negative bias here. I think the print said it's around 11 volts. Screen grids are tied together in this particular tube, so they'll have to be derived from the 400 volt input rather than the normal screen taps that would be out here on the output transformer. And then we have the relay coils are driven from the 6.3 volt filament voltage here, and the foot pedal will go out here. There'll be a bright switch and a clip amp switch. So that's it for the kind of the proposal for this amplifier. Okay, I came up with a schematic for the 3-tube amplifier. We got a 1/4-inch jack input, the preamplifier and the clipping amplifier here. The inputs I have in parallel. The clipping amplifier, I have a trimming pod in here to kind of adjust how much clipping is placed into the preamp tube. This tube will be the clean side, and when this is injected in via K1 here, it'll be the dirty signal for clipping. So the 6U10 center section for the preamp, and this is the 6AV6 for the clipping circuit. Then it comes off of that stage into the bass treble and volume control. Also the bright circuit comes off of here through a .001 cap, and when the foot pedal hits the K2 relay, the bright control is fed into here also. Then we have the buffer for all this tone control and volume control circuitry. The buffer feeds the phase inverter, and the phase inverter here is another section of the 6U10, section 3 I believe, and then that feeds the 6DZ7 for output to the plate transformer. We have a negative bias voltage here with a potentiometer to adjust the grid bias on the output tube. We also have a standby switch here on the front of the amplifier, and by opening the cathode it'll put the amplifier in standby mode. We're going to drive this with 400 volts, and then we have our drop-in resistors to bring down the voltage for the stages as it comes along all the way to the preamp. And this is the feedback, where the feedback comes in off of the output, 8 ohm output of the transformer. We're going to give this whole thing a try and see if it works. Here we have the filaments, 6.3 volts coming in on the 400, and I start out with a -21, which actually could be anything greater than -12 for the bias, the negative bias. And we have the relays here. There are 5 volt relays that are powered from the 6.3 volts, so got some drop-in resistors here. On the relays, a couple LEDs in parallel with the relays to show where the foot switch is activated. So the foot switch will connect here. So there'll be 2 switches on the foot switch, one for the dirty channel and one for the bright. So this is pretty much the schematic. The way it stands right now, it's probably going to change, or values are going to change. We're going to hope for something out of this project. We'll start doing a printed circuit board for this. This is the chassis layout. It'll be a 6x10x2. In the top layout here, going to have the transformer, then the 3 tubes. 3 tubes will go 6AV6 to the left, and then to the right the 6DZ7. Front panel will be 1/4-inch jack input, then bass, treble, bright, volume, power switch, standby switch, and the bright and height gain foot pedal LEDs. The rear panel has the 120 volt input, heatsink for the power supply. We'll talk about the power supply later. Mini fan, a 4/8/16 select switch, speaker, quarter jack, and a pedal quarter jack. So that's the chassis layout for the guitar amplifier. This is the switching power supply designed for the tube amplifier. I'll do a video on this separately. This derives the 400 volts plate, the 6.3 volt filament, and a couple other voltages. So this is what I'm going to use. This is the PC board layout for the 3-tube guitar amplifier. Got pretty much everything here. Just going to add the ground plane. Top side of the board, which will be in green. Top side also is carrying the heavy filament current, 6.3 volt. But the ground plane will pretty much grab all grounds. So if I bring the ground plane back up, this is what the top will look like. Be all solid copper here on the top. So hopefully the board will come out. I'm etching this myself, just like the power supply, because it is a prototype. I'm going to do this 2-sided board, and we'll see how it comes out. Okay, this is a block diagram here of the power supply, the transformer, the jacks, and the amplifier board. This is the wiring diagram that I want to use to kind of help put things together here. On the amplifier board, I've got screw terminals set up here for the minus 21 bias, the 400 volts, ground, 6.3 volt filament. A speaker ground comes into here. The 8 ohm from the transformer comes in and then comes back out because I tap the 8 ohms for feedback. And there's a ground and then the standby switch, which opens the cathode on the power tube. This is the plate connections to the power tube. I brought in the screen lines, and all they do is tie to these screws, but really don't go anywhere because I can't use the screen taps. The blue and the brown go to the plates. So this is all set up here for the I/O to the amplifier itself. Transformers over here on the back. There'll be a 4, 8, 16 ohm switch, which the way this Hammond transformer is configured, I needed 3 gangs of a 3-position switch in order to do this. The speaker jack that'll be on the back. Then this is the foot pedal jack, which comes over here to J1. And then we've got the power supply outputs. This power supply designed has a minus 21 and a plus 21, not using the plus 21, but using the minus 21 for the bias, and then ground. And then there's a 5 volt for a little fan here, 6.3 volt filament, and 400 volt plate. So this is the wiring diagram for the amplifier. So let's be able to start building it now. Okay, I built the amplifier and got the chassis all drilled out, painted, parts all mounted here. Now it's going to be time to test a few things. First, I'm going to double check all this wiring, make sure that everything is set up just right here. But it looks like it's right according to the wiring diagram that I made, so it should fire up pretty good. Here's a top view of the where the tubes go, and also the front view. I just have labels, paper labels for now on it because it is just a prototype, and the rear view of it. So we'll hook it up and run a few tests. Okay, we're set up for testing some voltages here. It's powered up, and we're going to measure 3 voltages. The 6.3 volt filament is pretty much right on 6.3 volts. The input plate voltage, the amplifier, is about 408. The negative bias on the 6DZ7 is around about 11.6. The spec was 11. I adjusted that in with this pot right here. It looks like the voltages are in pretty good shape. Okay, I'm feeding the amp 1000 hertz, and the signal looks pretty good. Got an 8 ohm rheostat on here. I'm across the entire 8 ohm, and I'm on the 8 ohm tap of the transformer. Even though this Hammond transformer isn't really set up for 8 ohms, it's more 10 ohms, but I'm going to go ahead and test it into 8 just to see what we have here. One thing I like about push-pull is, right, what I try to strive for is to get symmetrical clipping. I'm going to try to see how symmetric the clipping is. It's not too bad. It's a little more clipped on the top than the bottom, which tells me there's a slight mismatch between the 2 sections of the 6DZ7, or the grid bias is a little bit off on one or the other. But it's not bad. It's a good symmetry there. There's the clean. There's the dirty. So the dirty channel that's the clipping of the dirty channel. And that's full volume with the dirty channel. Okay. This is the bright. And the bright at a kilohertz is probably not going to do too much. Bring it up to 4K, and we'll see if the bright starts making a difference now. There's the bright. So I'm adjusting the bright control here. And it's putting it into clipping here. So there's bright. Back it off. And if you hit the foot pedal, that gets rid of the bright. So the bright channel is working. I'm not sure if the frequency is right where we want it, but I can always change that capacitor that's in series to give it the high pass. Now I have to run a couple more tests on each stage. I'm first going to look at they call the dirty stage here, the 6AV6 at R31 in the plate, and take a look at the signal there. And it's quite clean, but remember that this tube drives the 6U10 preamp stage, and that's where the clipping will come into play for the dirty channel. It looks like a pretty clean sine wave. I'll try clipping it just to see what we have. So it's a pretty soft clip, but this tube will never really see clipping. It's the other stage that'll see the clipping, because that's a pretty hot signal going into the 6AV6. There's 10 kilohertz. Okay, I'm going to put the probe on R2, which will be the plate of the clean input stage, or the preamp stage of the 6U10. And we'll take a look at that with the clean input, and then place the 6AV6 in front of it by pulling K1, relay K1, and see what the clipping looks like at the preamp output here. So here's the preamp output with 1 kilohertz coming in. I do have a 20K resistor here in series with the input out of the oscillator. Okay, so there's the input signal. Now I'm going to put in the high gain, and that put the scope way up. And there's the dirty channel clipping. Now I've got the oscillator real low. If I bring that up, that's the dirty channel clipping at the output of the preamp. So if you bring it way down though, it'll be clean because it's extremely low input level. But from a guitar pickup, it'll probably be about right here in the dirty channel. So that's what the dirty channel looks like. So we'll turn that off. Next we'll take a look at the tone control buffer amplifier. So now I'm putting the probe on R11 and pin 10 of the 6U10. That's the tone control buffer. And also the feedback comes in there too. So we've got the feedback off the 8 ohms. That has a pretty good signal there. And that's with the volume all the way up. And there's the treble control. It's skewing just a little bit there. So I might have to change some parts there to, although that is all the way up. So I'm going to try the bright just for the heck of it. Okay, there's the bright But then again, the volume's all the way up. This bright pot is a little iffy. Okay, so anyway, we got a fairly decent signal there at the output of the tone buffer, tone volume control buffer. This bright pot is a little iffy here though. Okay, we're going to look at the phase inverter, which is the third section of the 6U10. So we're putting a probe on R17 and R14, which would be the plate and the cathode. And that looks real good. The voltages look pretty symmetrical there, and so does the phase. So the phase inverter is looking pretty good going into the 6DZ7. Now I'm going to look at the two plates of the 6DZ7. That'd be JP21 and JP25, and we'll see how well that's doing. Yeah, it looks like we got pretty good symmetry there too. Pretty good symmetry there too. It's off maybe just a little at the bottom. So there is a little bit of a mismatch there, which I noticed during clipping too. So I'll have to maybe take a look at that. Okay, I readjusted it for 10.3 ohms from the earlier calculations with this particular transformer and output tube. The 8 ohm is 10.9, so I'm going to put this resistor on there and take another look at the output waveform. This will be a match for the tube, and like I said earlier, I got a different transformer I really need to get for this, so I'm going to try this 10 ohm. Okay, I got 10 ohm load in there now for a good match for this transformer, and it did not change the symmetry of the clipping at all. So it's not an impedance mismatch causing it. So I guess at this point I'm not going to worry about it. But it's not too bad of a waveform coming out of there. So I guess the next thing is to have someone play guitar through it and see what it sounds like. This is Steve at Music Solutions here, playing some licks through my amplifier. A lot of gain there, Steve.
Damn straight, bro. How many watts?
15.
Hell yeah. Yeah, right on, bro.
Cool, Steve.
Yeah.
Thanks.
You betcha. So 6AV6 preamp?
Yeah.
Okay. And then what's this?
Very, very high gain.
What's the 6U10?
That's one 12AX7 and two 12AT7s.
Oh, it's one of those.
One of
Okay.
those. Ampeg used those one
Okay.
time.
And the 6DZ7?
That's a real rare, two 6V6s in one tube.
No shit.
Yeah.
Awesome. Yeah.
Yeah.
I like it. I like
Thanks,
it.
Steve.
Right on, bro.